Welcome to the unit on exponentials and logarithms. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely, simplify and evaluate expressions involving indices without a calculator, understand the laws of indices and apply these laws to algebraic expressions to simplify them, and given a set of data, sketch the line of best fit and determine the gradient and intercept from the plot. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Here are some of the laws of indices. These laws can be used to simplify powers of the same base. We're now going to look at review exercise 1. We are going to begin with review exercise 1a. Given that x equals 3 and y equals minus 2, evaluate 4 to the power x without a calculator. So let's solve this. 4 to the power x equals 4 to the power 3, as shown here, which is of course equal to 4 times 4 times 4. And this is equal to 64. Now for review exercise 1b. Given that x equals 3 and y equals minus 2, evaluate 2 to the power y without a calculator. So let's solve this. 2 to the power y equals 2 to the power minus 2. Which equals 1 over 2 squared. Which is of course equal to 1 over 4. And now let's have a go at review exercise 1c. Evaluate 3 to the power 2x minus 1, given that x equals 3. So let's solve this. 3 to the power 2x minus 1 equals 3 to the power 6 minus 1, which equals 3 to the power 5. Which equals 3 times 3 times 3 times 3 times 3. And this is equal to 243. And now for review exercise 1 part D. We're going to evaluate 5 to the power 1 minus y, where y is equal to minus 2. So 5 to the power 1 minus y is equal to 5 to the power 1 minus minus 2, which equals 5 to the power 3. And this equals 5 times 5 times 5, which is 125. And now for review exercise 1 part E. Given that x equals 3 and y equals minus 2, evaluate 11 to the power x plus 2y without a calculator. So let's solve this. Substituting in the values for x and y gives us that 11 to the power x plus 2y equals 11 to the power 3 plus 2 times minus 2, which is equal to 11 to the power 3 minus 4. And this is equal to 11 to the power minus 1, which is 1 over 11. And now for review exercise 2a. Simplify 4 to the power 8 divided by 4 to the power 3. Since we're using the same base, we can subtract the indices, as shown in the given law. So 4 to the 8 divided by 4 to the 3 is equal to 4 to the power 8 minus 3, which is of course equal to 4 to the power 5. And now for review exercise 2b. Simplify c to the power 4 all squared times 3c cubed. Using the highlighted law, we can replace c to the power 4 to the power 2 by c to the power 4 times 2 to give c to the power 8. We bring 3 to the front as shown here, and then using this highlighted law, we can add the indices. So c to the power 8 times c to the power 3 is c to the power 11. Here are some more laws of indices. Using these, we're going to tackle review exercise 2c. We're required to simplify root x times x to the power 4 divided by x cubed. So root x becomes x to the power 1/2. We leave x to the 4 as it is, and x cubed is left as it is also. We can now add the indices, so x to the power 1/2 times x to the power 4 is equal to x to the power 1/2 plus 4, and we leave x cubed as it is again. So simplifying gives us x to the power 4.5 divided by x cubed. So this now becomes x to the power 4.5 minus 3. And so we are left with x to the power 1.5. And now for review exercise 2d. Simplify the expression shown on your screen. Root x to the 5 becomes x to the power 5/2. And the denominator becomes 7x to the minus 3/4 by using the highlighted law. And we now have 3 divided by 7, as shown, times x to the power 2.5 divided by x to the power minus 0.75. So we can now subtract the indices, since the base is the same, as shown, to give x to the power 2.5 minus 0.75, leaving us with 3/7 times x to the power 2.5 plus 0.75, which becomes 3/7 times x to the power 3.25. Before we examine review exercise 3, recall that the equation of a straight line can be written as y equals mx plus c, where m is the gradient and c is the y-intercept. Remember that the gradient is equal to the change in y over the change in x. Now let's take a look at review exercise 3. Plot the given data on a scatter graph and draw the line of best fit. Determine the gradient and intercept of your line of best fit and give your answers to 1 decimal place. So let's sketch this first. The sketch will look something like the one you can see on your screen. You can also see that an attempt has been made to draw a line of best fit through the data. Extending this line so that it crosses the y-axis will allow us to read off the y-intercept, which is 60.5. So we now have the value of c. What about the gradient? Let's draw a right-angle triangle anywhere along this straight line. The change in y is equal to 27.3. We can simply measure this. And the change in x is equal to 21. Therefore, the gradient is equal to 27.3 over 21, which equals 1.3. So we now have the gradient and the y-intercept. And therefore, the equation of the straight line is y equals 1.3x plus 60.5. This brings us to the end of this session. If you have understood its contents, you should be able to simplify and evaluate expressions involving indices without a calculator, understand the laws of indices and apply these laws to algebraic expressions to simplify them, and, given a set of data, sketch the line of best fit and determine the gradient and intercept from the plots. Thank you very much for listening.